Okay, so let's start. So this is a slide I picked from a friend. So we would like to acknowledge him. He's at UDS. So it seems his own has a lot of things. So and there is no time also. So I have to pick his own. So let's continue. So this is biological chemistry. The course outline. Can you see? Can you all see?
Yes, sir.
Okay, so we'll be looking at water, protein chemistry, amino acid, peptides of biological importance. So let's start. We also look at lipid chemistry, nucleic acids, enzymes, a bit of enzymes and catalysis, structure and function of carbohydrates. But those ones will be part of the subsequent slides. Chemistry of bacteria cell, cell wall of higher plants, biological membranes, transport mechanisms, mitochondrial respiration. Okay, so let's start. Okay, so let's start. So the properties. Hey, please mute your who is it? Who's audio? Raphael, Conde Felicia, mute your audio. It's left with Raphael. Raphael. So this Raphael, where is he? Abigail. Hello. Hello. Hello, Abigail.
Hello.
Where is Raphael? Okay, so let's Abigail, you can mute and let's go.
He has done it all. So
No,
he has done it
I did it.
Okay.
I've turned it off for him. Is it that what he does is that he will on it. When he on it, they go and put it somewhere and be doing whatever he's doing. So leave him. Exam time, he will see. Okay, so I'll be off your own. Okay, so water, properties of water. Water is the most abundant substance in cells. And water accounts for about 70% of a cell's weight. And most intracellular reactions occur in aqueous medium or environment, meaning that life on Earth began in the ocean. So let's go to the next slide. Structure of water. This is a water molecule. We have the oxygen, hydrogen, and there is a bond of 104.5 degrees. This is because the oxygen is more electronegative than the hydrogen. So you can see the dipole moment. This negative. This one has 2 minus. So it's dragging. It will be dragging or pulling this force towards itself. This one too will be pulling the force towards itself. Okay. So that is water for you. Hello. Okay, so like I said, so there is a dipole moment that's positive to negative or negative to positive. So electrons will be drawn from the positive to the negative, so more negative. So the oxygen has electronegativity, 2 deltas, meaning that 2 electrons. So it has what? Two electrons here. It has drawn this bond, this single bond, to itself. It has drawn this bond also to itself. So the stretching will produce what? An angle of 104.5 degrees. So let's also see. We have this is a chemical bonding between water molecules. So for the oxygen and the hydrogen, there is a single bond, which is a covalent bond. Then between the hydrogen of one water molecule and the oxygen of another water molecule, there forms what? A hydrogen bond. Another hydrogen bond here. That's between the water molecules. And there are 3 water molecules over here. 1, 2, 3. If you don't understand anything, you let me know, eh? Hello?
Yes, sir.
Okay. So, cluster of water molecules. So we have, okay, so when the water molecules come together, they form hydrogen bonds, several of them. Okay. But the bonds between one water molecule alone is what? Covalent, eh? But if there is between more than one water molecules, then we have hydrogen bonds. Okay, so water interacts electrostatically with charged solids. So water is a polar solvent. Polar means that water is charged. Water molecule is charged. It readily dissolves most biomolecules, generally charged and polar compounds. So water dissolves what? Charged polar or compounds that have charge. Water will dissolve them. Then, compounds that dissolve in water easily are called hydrophilic. Philia, what? We have the philia, is it philia love or whatever, brotherly love. So, love, philia. Hydrophilic means that it loves water. Okay? Hydrophobic, that's water hating biomolecules do not easily dissolve in water. What is a water? An example of a water hating biomolecule: akpeteshi or alcohol. Oil hates water. So when you put oil in water, there will be formation of what? Emulsion, because water hates oil. They don't mix together. Acid and basic properties of water. This is what? This is water molecule, another water molecule. So when a hydrogen leaves its hydrogen, its electrons, so if this hydrogen leaves its electrons and goes to attach to this one, this molecule, water molecule, then we get this structure. So 3 hydrogens, 1 oxygen. So the hydrogen coming is like when you are traveling from here to America. You will leave your cocoa farm, that is the negative charge, and say that, oh, my wife, take all the cocoa farm and take care of the children. I'm going to America to hustle and come. So you will come to America empty-handed and come and join with what? Obroni. So we have what? Hydrozonium ion. That's H3 plus, because one of the plus is a proton, because it has no electrons inside it. So it left its electron here. So this OH now becomes what? Hydroxyl ion. Do you understand? Do you understand?
Yes, sir.
Okay. So hydrophilic and hydrophobic interactions. So this is water is hydrophilic. It lacks what? Polar substances. And ethane is what? Hydrophobic. Hey, assembly. Okay, water is polar, ethane is non-polar, that's all. Okay, so from amino acid to protein, we have amino acids. These are amino acids. And may I ask this question? What is the basic unit for a protein? Mention your name and answer. Amino acids. Okay. So we have how many amino acids here? 1, 2, 3, 4, 5, 6, 7, 8 amino acids. So these amino acids will be joined together in a long chain to form what? A peptide. So a peptide is what? A protein that contains more than one amino acid. We will be doing that. So and it's a single strand. When this protein folds together, or different multiples of this long chain primary structure, when different ones are attached together and they fold, they form what? A protein. And a protein is a polypeptide. We will come to that. Okay, so a biomolecule or biological molecule is a term used to describe molecules present in organisms that are essential to one or more typical biological processes. Examples of these molecules are proteins. And the basic constituent of protein is what? Amino acids. We also have carbohydrates, lipids, nucleic acids. Nucleic acids are what? DNA, RNA. We'll be doing all those things also. Okay, so amino acids are the monomers that make up proteins. They are the basic unit or single unit of what? Proteins. Each amino acid has the same fundamental structure. They have the same structure across. So the precise amino acid content and the sequence of those amino acids of a specific protein is determined by the sequence of the bases in the gene that encodes that protein. We will be doing the central dogma of molecular biology. So when we get there, you understand this. So this is what? The genetic code. The genetic code. We have you. Let me explain something. When you are drawing, when there is what? Translation. Translation is what? Production of protein. Every protein or polypeptide starts with AUG. And AUG codes for what? Methionine. And that is called start codon. And the code is 3. Each genetic code has 3 units or 3 nucleotide units. So, and the protein, when this codon is presented, there is what? Stop. So there will be a stop to the synthesis of what? Protein or translation of protein. You understand it? So we have 3 stop codons: UAA, UAG, and UGA. I will teach you some, but you will do it in molecular biology with Dr. Akela. Okay, so amino acids. The chemical properties of the amino acids of proteins determine the biological activity of the protein. Proteins not only catalyze all or most of the reactions in living cells, they control virtually all cellular processes. So everything about you is protein. Everything. The insulin that transports glucose from your blood to the liver and the muscles is made up of proteins. Everything. All the enzymes in your body are proteins. We'll be doing enzymology. So history of amino acids. How were they discovered? There are 20 amino acids in nature. Asparagine was discovered in 1806. That's asparagus. That's the name. Threonine, 1938. Hey, I was not born by then. No. Glutamate, the common name is what? Wheat gluten. It was discovered from wheat gluten. Then tyrosine was discovered from what? Tyros cheese. Okay, so let's look at the basic structure of an amino acid. So amino acid, it has the amino group. Amino is NH2, so NHH or NH2. Let me see whether I can draw this on the whiteboard and see something. Let me see the whiteboard. Is there a whiteboard? Yes. So let's share the whiteboard and see. Can you see my whiteboard?
Yes.
So
Yes, sir.
N H 2 is the same as
Amino acid.
there are two no. There are two no. That means my dear, when I asked the question, did you answer? Please don't be please, I'm just joking. So I guess you can see what I'm drawing. So amino acid comprises of what? This is the amino group, amino. Amino is the same as this. I've just broken it down. Amino. Can you see? So, and this is what? Hydroxyl group. Hydroxyl group. So, hey, I said hydroxyl group. Carboxylic acid group. So we have this. This is carboxylic acid group. So this one is minus. So we have something like this. So carboxylic acid group. These are the two main functional groups on what? On an amino acid. So this is the same structure. This one COOH is the same as what? C double bond O minus OH. Do you understand? Do you understand?
Yes, sir.
Okay, so let me see. So the whiteboard. So let's erase. Okay. So you understand now. So when we say I'm now going to draw the structure of an amino acid, that's the basic structure of an amino acid. When you look at it, let me clean my board well. Okay, so the basic structure of an amino acid. Let's see, where is my pencil? Okay. Whiteboard. Okay. Okay, so let's now I'm coming. So an amino acid now is COOH NH2. Then this is our, we call it, this is the most important group. This H is always H. It doesn't change. This one does not change. This one too does not change. The only one that changes is this. Very important. we call it, very important, we call it what? The side chain. So this is called, the R is called side chain. Side chain of an amino acid. So this one is constant, this one is constant, this one is constant. The only one that changes is the R. Do you understand? Are you with me? Are you with me?
Yes, sir.
Okay.
Yes, sir.
Okay, so let's continue. So we are going back to our slides. Okay, so I guess you can see the structure now. So this is the amino group. This is the amino group, This is the C. This H does not change. The amino group does not change. The COOH, the carboxylic group, this is the carboxylic group, doesn't change. The only one that changes is the R, that's the side chain. And this carbon is called alpha carbon. Alpha carbon. It doesn't also change. So let's look at some structures. And these ones you have to memorize them all. So we have what? The amino group, carboxyl group, hydrogen, then the R group. The R group is what changes. So for instance, if you pick an amino acid called alanine, alanine has the R group to be what? CH3. When we come to valine or valine, it has a side chain to be CH3. This R is now what? CH3 bonded to CH3 bonded to CH3. When you go to lysine, this is what you see. Can you see lysine structure fully, or something is covering it? Okay, so lysine has 4 CH2. CH2s are 4. That's why 4 is into outside the bracket. 4 CH2. Then it ends with what? Let the thing go. Something is covering the screen. 4 CH2. It ends with what? NH2. This is lysine. Then aspartic acid is also here. Okay, so these are the 20 amino acids. We'll be tackling them one by one, but you have to study them and know their structure. Start drawing them. Annabelle, you have to be drawing them. Okay, so glycine, the side chain is what? Only H. This is constant. The amino group is also constant. The carboxyl group is also constant, but the only thing that changes is the H. So whenever you see an amino acid with the side chain being H, it is called glycine or glycine. Okay. Then proline, this is the side chain, CH2, CH2, CH2 bonded to NH. So this structure is the side chain for proline. This is the carboxyl group, this is the amino group, and this is the CH. This carboxyl group is constant, this amino group is constant, this H is also constant. The only difference is this CH2, 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 which is what? A cyclic what? Structure. Okay, so glycine, like I told you, glycine has the side chain to be H. Proline has the side chain to be CH2, 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 NH. So for glycine, this is the structure of the side chain. Hey, is it glycine? That's proline. Okay. Okay, so amino acids can be grouped or classified into different groups based on their R group or side chain. Nonpolar aliphatic R groups, aromatic R groups, polar uncharged R groups, positively charged R groups, negatively charged R groups. So let's go. So we have the nonpolar aliphatic R groups. Whenever you see aliphatic, it means what? A long chain hydrocarbon. What is a hydrocarbon? What is a hydrocarbon? Please, I'm recording. Then the recording doesn't keep long. So answer. What is a hydrocarbon? Answer fast.
It is a compound who contain hydrogen and carbon.
Who said this? Mention your name before you. Raphael. That's good. Very good. Clap for Raphael. Okay. So it contains only hydrogen and carbon groups. So we have what? Hydrocarbon. So and it is aliphatic, meaning that it is a straight chain. So if it is a benzene ring, what do we call it? If it's a benzene ring, what do we call it?
Aromatic compound.
Hey, Raphael, you are good though. So is Annabelle there? Is Felicia there? And they are not talking.
Yes,
Okay.
sir.
So Felicia, you don't know hydrocarbon, you don't. Okay, let's continue. You know and you are not talking. Raphael is taking all. Let's continue. So we have the side chain to be H, that's for glycine. Alanine, side chain is CH3. Like I told you, the amino group will be the same, the carboxyl group will be the same, the H group, the H hydrogen will be constant, but the side chain, which is R, will be changing. And that is what classifies or differentiates one amino acid from another amino acid. So alanine has CH3. Valine has CH bonded to two different CH3s. Proline is what? A ring. Then we come to, this is isoleucine. Hey, this is leucine and this is isoleucine. We also have what? This one is what? Let's see the name. The name is, it has a sulfidyl group. Sulfidyl. Whenever we say sulfidyl, let me bring the structure. So that is a methionine. It has a sulfidyl. Whenever you hear sulfidyl. Oh, let me clean this. Let me clean. Okay, so whiteboard. Okay, so sulfhydryl groups. Sulfhydryl. Sulfhydryl. Don't mind my spelling, So SH. It has what? SH. This is a reduced sulfur group. Then if it is an oxidized, so if this one is a reduced sulfur, also sulfhydryl group, so reduced. If it's oxidized means what? Oxidation means what? Removal of hydrogen, and so this is reduced, so addition of hydrogen, reduced. Then when we remove the hydrogen, it becomes what? Oxidized. Okay, so let's go back to our slides. So so it has sulfhydryl groups. There's a sulfhydryl group here, over here, oxidized sulfhydryl group. So this is methionine. Methionine. We'll see the structure later. So we have amino acids also which have what? Aromatic group. Aromatic means what? They carry benzene ring. I guess you know that this is a benzene ring. Okay, so this is a benzene ring. So this is, how do we call benzene ring? What's the name for benzene ring? What's the name? How do you call a benzene ring? Or what? Or what? Hey, and the my bomb papa. And yeah, no. Hey, so is Felicia Conde there? It's it's more. Okay, so it's phenyl. And yeah, phenylene. Phenyl. Let me clean the board. Let me clean the board and you look at it well. Let me see. Phenyl group, Phenyl. Oh. So we have a phenyl. Yeah, some cranny, Can you see? Hello? Hello? When there is a benzene ring, how do you call a benzene ring? Hey, you people are still saying aromatic. And what? Phenyl. Very good, you are following. So let's go. So this phenylalanine means that this is alanine. No? When we go back to the structure of alanine, the R chain has only CH3. But we have added a phenyl group or an aromatic group to it. That's why we are calling it phenylalanine. And let's go and see alanine again. So the alanine, you can see alanine is here, CH3. So when we add aromatic group to it, or phenyl group to it,
we are not seeing anything.
Can you see?
No, sir.
Can you see?
No, sir.
Okay, let me share it again. Can you see?
No, okay, sir, please, it has now come.
Okay, maybe your network. But others were seeing it.
No, sir.
Okay, so can you see phenylalanine now? Let's see.
Yes,
so you can see CH3, Can you see alanine?
Yes, sir.
What is written in red? CH3. So when you add a phenyl group, to it, it becomes a phenylalanine,
Yes, sir.
So let's see. So this is phenylalanine. You have added a benzene ring to it. So the CH3, one of the H will share a bond with what? One of the H will leave, so that the phenyl group will come and bond with the CH2. Then tyrosine is what? Also from alanine, CH2 and aromatic ring. So this is phenylalanine. When we add OH group to it, it becomes what? Tyrosine. Then this is tryptophan. It has what? It has an imidazole group. This is a imidazole group. Tryptophan. Okay, let's go. So most of we will be doing some reactions of carbohydrates and amino acids. Tryptophan gives a chromophore, a color change. So let's go. So we have polar uncharged R groups. Whenever you see this is a polar means that it has OH group, or so OH group, but there is no charge on it. So we have what? Serine. This is called serine, CH2OH. Under normal circumstance, let's share a slide and you see something. Let's share this thing, whiteboard. Under normal circumstance, OH is supposed to be what? OH minus. But now OH is there bonded to CH2OH, or maybe CH3OH. There is no charge over here. So although this is a polar group, but this case there is no charge. So it is a polar although, but it is uncharged. Okay, so polar uncharged group. Then we have what? Another polar uncharged group, COH. SH is a sulfhydryl group. There is no charge there, but it's supposed to be. When it is reduced, it becomes a charge. When it is oxidized, that's SS, it becomes charge, because the hydrogen will leave and leave a negative charge there. We also have, this one is also polar. This one is polar, but there is no charge. This one too the same. So this is called, is it glutamine? And this one, the name will come. Coming shortly. I want the name too. Yeah, so this is asparagine and glutamine. Okay, so cysteine. Cysteine has a sulfhydryl group. Sulfhydryl group is what? Sulfur and hydrogen. We call it sulfhydryl. So sulfur and hydrogen, when there is reduction will mean that we remove 2 hydrogen atoms. Reduction means what? Removal of what? 2 hydrogen atoms. When we remove the 2 hydrogen atoms, we get what? SS, or sulfur bonded to sulfur. So this is oxidized cysteine. This amino acid is called cysteine because it has CH2 and CH and SH as a side chain, and another one the same, CH2 SH. So we have 2 molecules of cysteine. Some will say cysteine. So when you move the hydrogen, 2 hydrogen atoms, you get sulfhydryl groups. So this is what? 2 amino acids that have been bonded together. So we form what? A peptide bond here, and this is a dipeptide. We'll be looking at that shortly. Okay, so positively charged R groups. The positively charged R group means that there is a positive charge in the side chain. So you can see the amino or the ammonia over here, or the amino group is positively charged. Over here, amino group is positively charged. Over here too, there's a positive charge here, but we didn't show. So this is histidine, this is lysine, and this is what? Let me see the structure. Something is covering it. Okay, this is arginine. Negatively charged R groups means that it has what? The proton has left, leaving COO minus. COO minus. This is a carboxylic acid. So let's go to the whiteboard and let me explain. So you can see COO minus. Oh, okay, COOH gives rise to what? Gives rise to COO minus plus a proton. This can also be written as C double bond O minus and what? A and O. This is a carbonyl carbon, and this is O minus. Okay, so this is carboxylic acid, and this is carboxylate. Then this is a proton. So let's go back to our slides. So this is it. So the proton has left. So we get aspartate and what? Glutamate. But if the proton were to be there, we will call it aspartic acid. This one will be called glutamic acid. But the proton, which is an acid, has left. I guess you remember your acid, bases, and salts. Hello? Hello?
Yes.
Yo, there may be some question. Okay, so let's go to zeta ion. We'll be ending very soon. Then Monday we start the proteins. So a zeta ion is what? An electrically an electrically neutral compound that contains both negatively and positively charged groups. So if any compound that has negative charge and positive charge is called and stays neutral in a solution is called what? A zeta ion. And the pH at which a given amino acid exists in a solution as a zeta ion is called the isoelectric pH or isoelectric point. So let's see. This is amino acid. Let's forget about the side chain here. This is a basic group. Anytime you see ammonia, it's basic. What type of base is it? You've forgotten arrhenius acid, arrhenius base, Bunsen-Lowry acid, Bunsen-Lowry, and Lewis acid, Lewis base. You have forgotten them.
No.
So this is a Lewis base, and this is an acid. So the acid and the base. So when you add a proton, this one there is no charge, so there is no acid, there is no base. But this one becomes what? A proton acceptor. So it becomes what? A proton acceptor, and this one becomes what? This one gives its proton to the NH2, becoming positive. So this one basic and this one acidic group. The acid donates the proton, and the base is what? The receiver of the proton. Lewis acid, Lewis base. So this is a Lewis acid, this is a Lewis base. So they form a zeta ion. Zeta ion has no charge because this charge will cancel this charge out, so that there will be what? Electrical neutral. Okay. Amino acids can act as what? Amino acids can act as both an acid and a base. Addition of an acid. So we can add a proton. Addition of an acid. Proton is an acid. When we add this proton to this negative O, we get OH. We can also add a base, negative OH, and negative OH, meaning that this proton will leave and come and bond with this to form water. I guess you know that hydrogen plus OH, proton plus hydroxyl group will form water. You all know? You all know this? Okay.
Yes, sir.
Okay, so we form water, and we form what? This amino acid, which is has a basic group here, and this one has an acidic group. Let me pause the video and the recording and start another recording. So just give me 2 seconds.